so this is the second part. What I'm going to do in this video, I think I'll define the boundary conditions, and I think I'll solve it too. I think I'll get that far, okay? The boundary conditions, the load steps, and then we'll solve, okay? Depending on how long it takes. All right. So remember, we're going to have two load cases, right? So I'm going to have three sets of boundary conditions. One set is going to have the displacement boundary conditions at those two nodes. The second set is going to have the 1,000 pound force. And then the third set will have the two 500 pound forces. And that will allow me to define the load cases or the load steps such that for the load case 1, we will be using the displacements in set 1 and the 1,000 pound force in set 2. And for the second load case, we'll use the displacement conditions, the SPCs in set 1, and then the downward 500 pound forces in set 3. All right? I probably should have labeled them here, maybe, but we already got started, so this is what it'll be. Okay, so when we do that, we are going to have to do the different sets that hold the different boundary conditions. They're called load collectors. So if I right click in this model window again and I do create, you'll see there's a thing called load collector. And so that's going to, now we got a separate little tab of load collectors. So I'm going to make this first one be SPCs, because that's the collector that's going to have the displacement boundary conditions, the SPC conditions, okay, at the first node and the fourth node. I believe that's node 4. All right, so where we define all boundary conditions, load, moments, forces, distributed loads, SPCs, MPCs, is in this analysis radio button option. So let's pick that. And they're going to be a constraint, okay? So we're going to pick this button here that says constraints. And there's you can use different types of constraints, but we're not going to use these. We're going to just focus on SPC. So I'm going to make sure it's set to SPC. And you can see here I've got buttons that allow me to constrain any of the degrees of freedom that I want. You can unconstrain those. Like, for example, if I do this, I'm just constraining the translation in the X direction to be 1. You could set it to a non-zero value. You could make it move an inch. Okay? So we won't do that necessarily, right? But we're first going to fully fix this upper left node, and they're all going to be set to 0. Right, so that's what I did here. So I've got the 3 translational degrees of freedom, X, Y, and Z, and they're all set to 0. I'm not setting the rotational degrees of freedom. I mean, you could, but it does nothing because these elements don't have any rotational stiffness to them. Okay, and I'm going to put it at this node here. So I'm going to pick that node and then hit create. Did I do it? Create. Wait, what's going on? Looks like it's not doing it. Didn't. Okay, let's try it again. Sometimes it does that. Let's do this again. Constraints. Maybe it's because I talked too much. There it goes. Okay. And so now you can see you get a little triangle like the cartoon pictures we do in class, and it's fixed degrees of freedom 1, 2, and 3. The 3 translations. Now let's go and pick this node, but at that lower node, we wanted to allow it to move in the Y direction. So I'm going to unclick that DOF2, which means I'm not going to constrain the Y degree of freedom, so it's free to slide there. And then if I hit create, it creates a little triangle as well, but you can see it only has 1 and 3, because those are the degrees of freedom that are fixed. All right, so we've got our SPCs defined. Okay, now let's put the forces for the first load case. So I'm going to make a new load collector to hold those. So create load collector, and let's call it, call it horizontal force. And so when I create it, you can see it's bold-faced, so it's current. So when I create load type of entities, it'll go into there. All right. So we want to create a force. So I'm still in the analysis radio button, and I'm going to click on force. And again, this has the options that go into that type of card. So we pick a node, we pick a magnitude, and then a direction. So you can pick it to go in the X direction, the Y direction. You can also pick 3 points to define a direction as well. So this is a force that goes in the X direction. So I'm going to click X direction, and it's a positive 1,000 pound force. So I'm going to set it to 1,000, and then I'm going to pick the node that I want it to be at, and I'm going to hit create. And now you can see, it's a little hard to see because it overlaps that, but there's a little blue force. It's the same color as the load collector component, and that's created the force, the 1,000 pound force there. All right, so that's good. Now I want to create now the 2 down forces, but again, I'm going to put them on a new load collector because I want to use them separate from the horizontal force in the second load case. So I'm going to right click in here, hit create, load collector, and so now I got a new load collector, and I'm going to call this down force. All right. And you can even, that color looks a lot like the other one, so I'm going to change it so it looks quite a bit different. So I do that so it looks different. And fine, so now these are going to be forces in the Y direction, but it's a negative Y direction. So the way we do that is we change the magnitude to a negative number. So in this case, it's going to be negative 500. And I can pick these 2 nodes, and you can see the down force collector is active. So when I create them, it'll go in there. And there they are. Okay, so there they are. Now, if you do make a mistake, and like you put them in the wrong collector or something like that, the tab that allows you to like edit, delete, modify, is under tools. So you can move things to different layers through organize. Like I can pick no, let's not do that. Let's pick loads. Like I could pick this force and move it to another load collector, right? Or you could delete things or move them around. Most of that stuff is in here, okay? And I'm doing this correctly, so I don't have to edit it, but that's the way it goes. Okay, so now we have all the entities defined, the boundary conditions and their different load collectors. So now, before we solve, we have to define the load steps. So remember, we need the 2 load steps, 1 for each one of these load cases. So again, I'm going to create those by clicking in the right-hand side of the model window, or right-clicking in the model window, which is on the left-hand side, I should say. And so we're going to create, and then you're going to see a load step. So the first load step, I'm going to call horizontal load. No, I'll call horizontal load, I guess, right? And down here are the different options, okay? Maybe I should slide this and make this a little bit bigger so you can see this. So first thing, we want to specify what type of analysis we're going to do. So right now it says generic, which doesn't do us much good. It doesn't do anything. So we're going to do, so these are all the different options you would have with OptiStruct or Nastran. So we're going to do linear static. Almost every analysis we do in this class can be linear static. So I'm going to pick linear static. And then here are the load collectors that have the SPC conditions and the load conditions. So here for the SPCs, I'm going to click on this. and we're going to select, here are the 3 load collectors that we defined. So I'm going to select SPCs. You can see it highlights them on the screen, and it's okay. So this load case is going to use all the entities in that load collector to define the SPCs. And for load, I'm going to pick the horizontal force because that's the one we want there, okay? And we're almost there yet, except there's one other thing that we want to do, okay? And this is because I want to output certain values to that opti file that I mentioned in class. So for 1D and 2D elements, well, not so much for 2D elements, but when we do 1D elements, you know, this will be helpful, okay? And usually for writing your reports and whatnot. So we're going to change the output options. So if I go down here, you can see there's an output box. I'm going to click on that, and here's a bunch of things I can output. So, you know, these are all different options that go into the load step card, okay? So I'm going to write out the stresses, the displacements, the element forces, and also the reaction forces, okay? So for displacements, we're going to click displacement, and you get a bunch of options. The important one is format, and we're going to select opti. So that means it's going to write the nodal displacements in this ASCII opti file. Okay, we're also going to write out the element forces. So that's this one that says EL force. So I'm going to click on that. Again, there's lots of options, but I'm going to pick the format one and set that to opti. So it's going to write those to a text file. Next, we want to do, what's next down the order here? None of those. Well, there's the SPC. These are the reaction forces. So SPCF is the reaction forces. Those are the forces that enforce the SPC conditions. So again, I'm going to click on that and change that to opti. And I think that's everything. Oh, I didn't do stress yet. So then the last one is stress. Same thing. Format, opti. So now we've got the stress, the reaction forces, the element forces, the forces inside the elements, and the displacements all being written out. So, you know, that's how you specify that. And you can do different outputs and all that sort of stuff. There's a lot of options, but we won't get into all those. So there we go. So now we're good. So that's the downforce model. And oh, I'm sorry. That's the horizontal force load case. Wait, what am I doing? Horizontal load case. There it all is. Okay, so now let's make another one, and we're just going to change, instead of using the horizontal load collector, we're going to use the downforce load collector. And so you could create a new one and set everything, but I'm kind of lazy. So it's so similar. I'm just going to right click on the horizontal load one. I'm going to say duplicate. And so now you can see it makes a duplicate called horizontal load 1. So let's change this to download. I'm just going to rename it. Oops, spell it correctly. So now we've got another load case which has the download case. So now, right now it's exactly the same as the horizontal load. So that's not very good. But what we need to do here is change the forces from the horizontal force to those download forces. So we're going to go to the load SPC, this field here, click on it, and change it from horizontal force to down force. And so now you can see it highlights the two 500-pound down forces. It's going to keep everything else the same. So it uses the same SPCs, and it also outputs the same information, the stress, the element forces, the reaction forces, the displacements, to the opti files. Okay? And so now we're actually ready to run. So let's save it. So you've got the mesh, it's fully meshed, it's got all the elements defined, we have all the boundary conditions defined, and then the two load steps. And so now we're ready to run, and if I'm good, we should get no errors, but sometimes we get errors, but whatever, we'll see. So to run it, it's also under analysis, so we're going to pick analysis, and you can see this button here says OptiStruct. So if I pick that, that's the window to start running it. And basically, all you have to do here is just hit OptiStruct, this big green button, and that'll start it running. We will see another window pops up that gives you the status of the solution. It's very quick because it's just 6 elements. And I got analysis completed, so I had no errors. If you have an error, it'll show up here. If you do get an error, read those. They're usually very good at explaining what it is. If you ask me what it is, the first thing I'm going to ask you is, what does the error message say? And usually from that, you can figure out exactly what was the error. Like, a lot of times people forget to assign properties to all the elements, or maybe there's not boundary conditions, or sometimes you forget to do a load step. You make the load collectors, but not the load step. I mean, they're all pretty easy mistakes to make. And when you're starting, you'll make mistakes, okay? But we're good. So this ran. It worked. So I'm going to stop now. And then the last video, we're going to look at the results in Hyper-View, and then also look at the ASCII files, the OPTI files, okay?